Hi, here we have an old friend. It's a NuTone IM3003. This particular IM3003 was made around 1988, and actually it's a set that I repaired all the way back in 2014. And as a brief overview, it's an AM/FM Intercom Master Station. You have room control switches behind the door here. When it's powered up, you have red LED display for the clock and for the radio station numbers. It's a tried and true NuTone intercom. Came out in 1984 and it was available all the way through the end of 1993. One of the problems with 3003s is, it's not really a problem with the 3003, but it's something that just happens. If we flip it around, you can see here that this is the position that it would be in when it's mounted up against your wall. Here's the sheetrock right here. And you have three boards. You have the clock display board here, and the tuner board here, and the main board down here. And when it's closed up in the wall, all of these boards are horizontally positioned, so they act like little shelves. In the case of this particular one, these people got it back, reinstalled it, worked great. They were very happy, they said. But recently, in the last few weeks, they had a water leak in their house. Water got down inside the intercom and it landed on the main board down in here, which I'm going to show you. Water leaks in intercoms are not good. Think about it this way. Would you take a cup of water and pour it into your Blu-ray player? I think not. Lots of times when there's water leaks in 3003s, all of the horizontal boards can get wet and the water puddles up, and what happens is it creates corrosion on the circuit board, and that causes all kinds of havoc. Here in this close-up shot, you can see all the green and white corrosion that has happened when the water landed on the board and puddled up, and it reacts with the chemicals and the metal parts that are left on the board. The chemicals are a byproduct of when the board was manufactured, and the end result of it is all of this green and white corrosion. This type of corrosion is very bad. Think about it like in the old days when you used to get corrosion on the battery posts in your car. That's not so much of a problem anymore, I don't think, but it's very similar to that. Not only can it eat away at the leads and legs of the components, especially if it's left there for a really long time, but it's also conductive, which means electricity can pass through it. So what you have is a massive amount of short circuits, and that's why the set doesn't work properly. When my customer contacted me about this, she said, well, the contractor was there doing some work to repair the damage from the water leak, because I guess it was fairly substantial. He opened this up and looked at this and he said, this looks really bad. I don't know if anybody's going to be able to fix this or not. But she called me and explained it all to me, and I said, sure, we probably can fix it. It's a 3003. If you can't fix this one, what can you fix? So she went ahead and shipped it off to me. And what I'm going to show you today is I'm going to show you how we deal with something like this, because while this looks really bad, and it probably looks really worse in real life than it does in the video, it's most likely salvageable. If for some reason it wasn't, we have replacement boards, so you can always go that route. But in this case, because of what it is, we're going to go ahead and give it a shot. And what I'm going to do is I'm going to show you how we deal with this. So this is not going to be entirely a step-by-step video. I'm not going to explain every single thing that we're going to do and as we go and what each part is. It's more of an overview of what can be done with a board like this. We'll see how it goes. This is entirely a make-it-up-as-you-go video. So first thing we need to do is get the board out of the set, and we're going to go ahead and disconnect some cables, 2 on that side, 2 on this side. You have to unplug the wires from the speaker, and then we're going to go ahead and take the screws out. There are 4 screws that hold the board into the back of the faceplate. And we're going to take off the cardboard insulator. This is obviously shot at this point, so I'll look for a replacement. And let's go ahead and pull the board out like this. And we'll take the rest of the set and the knobs and put them over in the tub. We'll go ahead and we're going to take the volume slides off because they're just in the way at this point. And what you want to do is you don't want to make anything worse. So a little bit of disassembly is good. I'm going to take this bracket off here. This is a support bracket. Strip it down to the board itself. Now we can have a better look at what we've got here. And there's a close-up. You can see the corrosion very clearly here. What's the basic idea behind this type of repair? Basically what we need to do is we need to unpopulate the contaminated area. Unpopulate is a fancy word for take all the parts off. And that's basically what we're going to do. A lot of this would clean away. We could leave the parts and clean around everything, but that's not the best choice on this. The problem with this type of corrosion, even though this has only been about 4 or 6 weeks since it happened, I think, that's enough time for it to kind of take hold, and I'll hopefully be able to show you some examples of what can happen. The biggest problem on here will be the integrated circuits. There's 4 of them, because these are dip packages, which means you have a plastic body and then there's little legs that come off each side, which you'll see as I take them out. And there's actually a space underneath each one. There's a gap. And the water gets under the gap and it makes corrosion underneath, and you can't clean that out without taking the parts off. So this is one of those, it's easier to just be all in on the project and go ahead and remove all the parts in the contaminated area. The contaminated area is primarily across here, and then it kind of angles down and goes down over in here. Oops. So this, we might take this socket out just to make sure there's no corrosion underneath, because you know water gets everywhere. It can get into the little skinniest spot that there is, and if you have corrosion underneath this socket, which is one of the interconnect cables, that can cause all kinds of problems in the way the thing operates, and we can't have that. So let's go ahead and start taking it apart. If you were paying attention, you might have noticed that I didn't power it up in any way at all, because I don't think there was any point in it. I trust what the customer tells me. Powering it up is not going to yield any kind of real information that I don't already know about it. When it's this massively damaged, there's really no point. Also, it's unlikely, even with all of this damage, that there's any problems with the other boards in the set. Because of the way the set is designed, this will be localized damage. It's not going to affect the tuner. It's not going to affect the display board or anything like that. It's pretty much just contained right here. So what I'm going to do is I'm going to desolder and sort of talk at the same time and explain what I'm doing. And basically I'm going to start from this side and I'm going to work across. Now if you're doing this yourself, one of the things that you're going to have to do is you got to keep track of what you take off and where it comes from. Like here are some transistors, and I have an advantage because I know what they are and I know where they go. Now one of the things you might be able to see, I'm going to try to show as I go, on the legs of this transistor, it would be the leg on this side. If you look really carefully, you can see a brown spot on it. That's where the corrosion has attached itself to the lead of the transistor. And if it's left that way for a long period of time, like months and months and months, it will slowly eat the metal away. It's like rust on your car fender. I've taken a lot of rusted transistors off boards. Sometimes what you get is one leg is still good and the other two are eaten away. And that's obviously not right. So that comes off. We'll take this capacitor off. That's a new one, but we're going to take it off anyway. This is really a mess. So I'm going to jump up and I'm going to do this integrated circuit. It's unfortunate because a lot of these parts were replaced just 6 years ago when I rebuilt the set. And now they're toast. So this one is desoldered. I'm going to go ahead and pop it off the board and show you. Try not to mess it up too much here. Alright, so you can see probably all the corrosion on the leads, the corrosion underneath, and the corrosion on the board. So you can see the rectangular spot where it was sitting. There's 2 rows of little holes, one on either side, and you can see the corrosion that's underneath it. This is why you have to remove these, because you can't clean that away thoroughly unless you take the parts off the board. So I think I'm going to do those first. Nothing more exciting than watching a guy sit there and desolder parts. Could you imagine how long this would take if you had to do it with solder wick, or if you were using one of those spring-loaded desoldering vacuum tools? It would take forever. Like that. And I'll take these off, because these are all in really, really bad shape. That one. That one. And no, these don't get reused. These get replaced. This is adhesive that was put down on the board when it was manufactured to hold the ICs in place as they went through the wave soldering machine. So let's go ahead and get rid of the rest of these capacitors. Get these out of here. One more. And now, this wire out of the way. This is a little voltage regulator. And what you didn't see happen, but I just saw happen, I'll show you when I take it off the board. Alright, let's pull this off. So, this is a little voltage regulator. It's in a TO92 package, which is the same configuration as a small signal transistor. And initially, let's see if I can hold it up so you can see it. You can see 2 legs, but it actually had 3 legs when it was new. Where'd the 3rd leg go? Well, it rusted off and it broke off when I desoldered that one spot right there. So this is 6 weeks of corrosion, and already the leads on parts are being eaten away. So we'll take this transistor out also, and we might as well take off this one, that, and see, this one is like right on the edge of the damage zone, but we'll get rid of that also. And I think the other thing is I'm going to take this socket off right here, because even though it's got corrosion on the top end here but not on the rest, but you know, in for a penny, in for a pound, you might as well just take it off while you're doing it. Hopefully it comes off pretty easy. Sometimes these kind of parts, which are beefy, are harder to get off the board because they're a tight fit, because they know that you're going to be pulling on it at times and they don't want you ripping off the board. Yeah, see, it's not too bad underneath, but you can see right here where my finger is, there is a little bit of corrosion under there. And you don't want to leave any if you can help it, because if you do, it's like rust on the fender of your car. I don't think cars get rusty, at least not in California that much anymore. But you know, you notice you got rust on your fender, you take it to the body shop, and the guy says, oh yeah, we can fix that, no problem, leave it for a week and we'll take care of it for you. And you go back in a week and you pay a lot of money, and it's all perfect, and they repainted it, and it looks like brand new, and you're very happy. And then, you know, about 2 years later, you walk out one morning to get in to go to work, and you notice there's a little bubble under the paint. That's because a little bit of the rust didn't get cleaned off, and it grew and grew and grew underneath the paint, and there you go. So that's not good. So we got most of the big parts off. We've got a couple ceramic capacitors that we're going to take off. This. And that leaves us with a bunch of resistors, couple diodes. I'm just looking carefully at how bad it really is. It looks pretty bad. So let's go ahead and get the take the diodes off next. And these little parts, sort of grab them with the side cutters, and I'm going to set them up there. That helps me remember where they went. That might seem odd to you, but it's not. Everybody's got their own way. Like that. Now, all we have left are a bunch of resistors, and we also have, if I can find one, these right here. These are jumper links. These are just pieces of wire that are bent over, and they make a connection that goes across the board because they didn't have enough room on the other side to create a path or whatever it is they needed to do. So they're jumper links. And jumper links are a pain in the neck to change, but odds are we're probably going to have to. Oh, one more little diode right there. That one. Okay, so I'm going to go get something and I'll be right back. What did I go get? I went and got this. What is this? This is basically a donor board. This is a board from another 3003. It's exactly the same board as this because I checked to make sure. As you can see, a lot of it's missing. Why is that? Because it has fairly extensive damage on the back where some contractor hooked up the power wires. Instead of connecting it to a 16-volt transformer, he wired it into 110 and the board went poof. Physical damage to the board is bad enough that it wasn't worth fixing, so we replaced it with another board. Those kind of boards become parts boards. The kind of parts we're not going to rob used integrated circuits or diodes or transistors or voltage regulators off of it. What we're going to rob off of it are things like jumpers and things like that that you can't readily buy. I don't have a selection of jumper links in a package somewhere that I can just open up and use, and we need to replace all the ones on here because they've all been corroded. So it's easier in quotes because it's a fair amount of work to do, to take them off a board like this and then put them onto a board like this once it's been cleaned. So this is a donor board, that's what it's for. And as you can see, like here, the socket's still here, so we'll take this socket off and put it on here, because a socket like this that was made in the late 70s, early 80s, you can't really readily buy something like this anymore. I suppose if you searched around forever, you might find something that's the same or similar, but it's just easier to have a direct replacement for the one that got damaged. So it's a donor board. Pretty soon, there's not much left on this. Pretty soon what I'll do is I'll scrap off the rest of the usable items and then it'll go in the trash. But you can see we don't waste anything here at all. We use it down to the very last little bit possible. So what we're going to do is I'm going to remove the jumper links and all the resistors now, and then we're going to clean the board. So this will take a few minutes, and I might make this a time-lapsey kind of thing. So if it looks like I'm going really fast, it's not because I drank too much coffee. And one of the things about removing jumper links that's a total pain in the neck is, while on the surface they're just little pieces of wire that are bent, on the back side where they're soldered, when they're put through the hole, the ends are bent over so they don't fall out, and they're a pain in the neck to desolder. And so what I'm actually going to, I think I'm going to do is I'm going to go through and clip them all in half, because that makes it easier to take out. Now, of course, when it comes time to transfer the ones off the donor board, you can't cut those in half, so that'll be extra exciting. See, and you want to be a NuTone service guy. This is how exciting this is. And the trick is, you just sort of have to sit here and work through it. And as I was taught a long time ago when I was growing up, I don't know what you're complaining about. It's not like you have to do a million. This is a little jumper wire. Why do they use a jumper wire instead of a jumper link? Because it's too far away. And that got desoldered accidentally, so we don't want it to fall out. Alright, 5 more to go. Now you might think, well, this seems awfully unnecessary, because if the wires aren't actually eaten away, why do you have to take them off? Well, because they will get eaten away. You can't clean it well enough to get rid of all the corrosion. The other thing that happens is, this is what's called a through-hole board, which means the leads of the components go through the holes and they're soldered on the back side. And what happens on through-hole boards, and you can now see all the little holes which correspond with all the little solder pads on this side. So when you put a component lead through this side and you turn it over and solder it on this side, the little hole doesn't fill up with solder. The solder pad is only on this side. So there's still a little hole. So you create like a pocket. And the pocket is empty. It's got a lead in it, but there's space around it. And the water gets down inside there into the pocket. And it sits there and it corrodes the lead down inside the pocket. And then you might think you cleaned it all well enough, but you probably didn't. And then you take your screwdriver and you push on it and you think, oh, that's pretty sturdy, that's all right. But then 4 months later, the corrosion eats away at the lead, the set stops working, then the customer calls and says, now you fixed it, you just did it, and now it's not working right, and then you got to send it back and do it again. So this is one of those do it right the first time kind of projects. And I think we've got to do that one too. You know, at this point, it's like, what's one more? You know, one more isn't going to make that much difference. Now, there's this wire right here, which I think we should replace. And even though I have it on the donor board, I think we're all right. I think I can remember where that goes. So we'll take the wire off. There. And this one. Which you won't be able to see, but I can see it under magnification. So the end of this little white wire right here, if you look really carefully under the magnifying visor, you can see the corrosion on the wire lead. That's not good. That. Okay, so what are we down to? So we're down to a bunch of resistors. That's all that's left. And now we're going to take all those off. And like I said, if you're doing this yourself, and if you don't have a donor board that is sort of your pattern as to where everything goes, you got to keep really close track of what you take off the board, because if you don't, you know, once you get it depopulated, it's just a bare board with a bunch of drawings on it, and you won't know what goes where. Almost there. Alright, we've got two more. And I think I'm going to take this little diode off right there. We've gone from a totally corroded board full of parts to a totally corroded board with no parts, which is what we want. Now we have to clean this. So first, you got to get a shop rag, because it's going to be messy. And so what do you clean it with? Well, there's a couple ways to go. I could take this and I could throw it in the ultrasonic cleaner. However, a board like this is not a good choice because it's got a mechanical relay, it's got two mechanical volume slides, it's got three intercom push button switches here, it's got the on-off switch here. Those kind of parts don't like the ultrasonic cleaner, especially the relay and the volume control pots. It just messes them up. You get all the liquid inside of them. It's impossible to get them dried out inside easily, and I don't want to take all of those off. If you're going to do it in the ultrasonic cleaner, actually what you would do is you would remove all of those parts, then clean the board, and it's too much work. What we're going to use is, we're going to do it the old-fashioned way. We're going to use toothbrush, and we're going to use a can of alcohol spray. I like the spray. And what we're going to do is we're going to spray the board with the alcohol, and we're going to take our toothbrush and we're going to scrub it clean. Now you might think, well, how come you didn't do that first? Well, because I didn't want to. It wouldn't have been as good of a video if I show up when it's all clean already. And then once you scrub it, we'll rinse it off. So a lot of people don't know alcohol is a really good cleaner. It's used a lot in electronics. It has an advantage of that it's not a solvent based, it's not like using paint thinner or something like that. Yeah, one more. Right there, it's got to come off. And it also, it dries really quickly. I want to take that transistor off. That one's not corroded, it's just in there really crooked, and that really bugs me. So alcohol, really good cleaner. Scrub it clean. Make sure you get all the holes cleaned out. Now some of the holes like here and here and here, remember I showed you the adhesive that they put under the ICs when they made the board? Well, I think the way they do that is they put a dab of adhesive and then they put the part in place, and the point of the adhesive is to hold the part onto the board when it goes through the wave soldering machine. And it always seems like there's a little bit of adhesive that gets inside the holes, and you got to clear them out. This doesn't have anything to do with the corrosion. This only has to do with being able to put the new leads back in place. Later on these boards, I think when they were made in a different place, they didn't use the adhesive anymore. They had some other method. So all I'm doing is I've got a 1mm drill bit, which is specifically designed for drilling holes in circuit boards, and although I'm not really drilling the hole, I'm just clearing out the adhesive. Works pretty much the same way. Like that. So, let's spray it again. And we probably should also do
the holes for our interconnect socket. I don't think they had adhesive, but they look kind of dodgy. That, and now we'll give the back a quick clean. There wasn't really any corrosion on the back. Do that. Rinse it off. Rinse off the front or the top. The other advantage to the alcohol is that it dries really quickly. In just a few minutes, it'll all be evaporated. Or, if you're in a big hurry, you could take some compressed air. And that's almost thoroughly done. And as you can see, all the stuff that came off the board when we scrubbed it. The board is pretty clean now. The next step for me is I'm going to go back, I'm going to work backwards. I'm going to replace all of the resistors and then all of the jumper links, which is pretty boring. So what I'm going to do is I'm going to stop the video and I'm going to do that, and then I'll come back before we install all the big parts, because the big parts are what everybody wants to see. That's the money, you know. Doing the little parts nobody's that excited about. Well, I'll do that, so I'll be back in a few minutes. Alright, I've got almost all the jumper links done. I saved the last one to show you. If you look on the board, if you ever have to do this, there are 3 jumper links right there. 2 of them are installed, the third spot is still blank, and if you look, there's a number next to each one. We've got 132, 133, and 134 all upside down. So what you do is, you take the jumper link off the other board, which very much looks like a little staple, although it's not, and you simply place it into the correct spot, 134, and if you took it off the board carefully, it'll kind of snap into place. And see, the donor board has the same numbers on it, so it's easy to keep track of what goes where. And once you've snapped it into place, then you turn it over. You make sure that the legs of the leads are poking through enough, and you solder it in place. It's that simple. So now all the jumper links are done. So now I'm going to go back, start at this end again, work back down this way, and I'm going to do all the resistors. So I'll be back in a few minutes. Alright, all the resistors are back in place, and now we're going to move on to the diodes. So we're going to start off with this one up here. That happens to be D104. That's a Zener diode. And then we've got 4 other diodes to install. You have to be careful when you install the diodes because they have a direction. There's an anode and a cathode, and they have a stripe on them, so you have to pay attention to the diagram on the board, which tells you which way they go about. And one right here. Oops, that one, see, almost went in backwards. You put it in backwards, it won't do the right thing, and odds are it'll make a short in the circuit. Alright, so we'll go ahead and solder these real quick. What I'm doing is I'm clipping off the leads so nothing sticks out the bottom. And while we're doing this, we're going to put these 2 ceramic capacitors back on. That one goes there. And this one goes down here. And let's see, what do we got left? Let's do the connector. So we're going to rob the connector off the donor board because that's the sensible way to do it. Get it off of here. That doesn't want to come off. Probably a little bit of solder on one of the pins, and it's hanging it up. And what happens on these is, if you don't get it desoldered all the way, when you try to pry the plastic piece up, the pins will actually pull out of the plastic piece and then they're not aligned correctly and it's a pain in the neck. So what you have to do sometimes is refresh the solder and then do it again, because new solder flows better than 30-year-old solder does. And if you get it right, it should almost just fall off the board. Not quite, but something like that. And then you've got to look, since I sort of monkeyed around with it a little bit, you've got to make sure that the pins are all even, like that. Otherwise, when you plug the connector into it, it won't make a proper connection on all the pins and it won't work right. Like that. Alright, so that's done. Let's see. We've got one resistor we missed. Right there. Let's do that real quick. You'd be surprised if you miss one resistor. Or you miss one solder joint. The whole thing may not work. That could be what my youngest son used to say, "Dad, that's the main resistor. That's the most important one on the whole board, because without that one in place, it isn't going to work." Now, we need to move this white jumper wire. There. And again, if you look at the markings on the board, you can see on the silk screen that long line that goes from there to there. That represents where the wire goes. So it is reasonably well thought out. That. And then there was the white jumper wire on this end. See, and all of these were somewhat corroded. Plus, you don't really want to take the chance that you're going to miss it. Like that. So that takes care of our jumper wires. Sort of mash them back down like they were when it was built. You know, part of the goal here is to make sure that you make it look as factory original as possible, which means you don't want to make it too perfect. So this transistor is going to go back in here. This is one I took off because it was hugely crooked, which is not uncommon, and hugely crooked bothers me. It doesn't make any difference about how it works. It was also slightly in the way when we were cleaning. Like that. I'm going to clip the leads off just a little bit. So that's a little neater. Not factory, but we'll get by. Alright, so what do we have left? Well, we've got some transistors that we need, which I believe are not those. I believe they're these. Yes, so we need how many? 1, 2, 3, 4, 5. 5. And these are the real deal. Not substitutes, not generic replacements, but the actual real transistors that were used in a 3003 back in the day. because if you look around, you can almost always find OEM parts, or at least original components. May not be from exactly the same company. These actually probably are. And if you can get the real thing compared to some substitute or your best guess or some generic part from some other company, let's go with the real thing. Let's do the real deal. And two up here. That looks like I clipped out one more than I needed. This one. And that one. Put this one over there, put it back in the package. That. Always remember, clip off the leads. Don't leave them long. Even though on a model like this, there isn't necessarily anything underneath it that you would really have to worry about. You don't want to take the chance that one might get bent over and touch someplace and cause a short, and then you got to look for it and do all that kind of nonsense. So one of the things we seem to be missing one resistor, which is R121. So let me go get one of those off this board. That. All right, and we're almost there. Now we need to put some capacitors back on, which I usually like to do before I do the integrated circuits. I like to do the integrated circuits last. We also have to put a voltage regulator in there. So let's get one of those. Wrong tub. And when you go to get your voltage regulator, you got to make sure you get the right kind with the right voltage. You definitely don't want to put a 12 volt regulator where a 5 volt is supposed to go, because that'll ruin your day really fast. Let me get some capacitors here real quick. We'll do the capacitors first. This one, and you'll notice ones I did 6 years ago are blue, and the ones we're using today still blue. Why? Because they're good quality capacitors. It's the ones that we settled on for most of the intercom work we do. And if it works, why change it? As long as they're still available. It's kind of interesting in the world of capacitors. There seems to be somewhat of a shift. Some of the series of capacitors that we normally use from the same manufacturer, these are all NuTone capacitors, which are one of the top 3 capacitor manufacturers in the world. Some of their values are becoming harder and harder to find because through-hole parts like this are not, very few new products use much in the way of through-hole parts anymore. And I guess those are the only, oh no, we need one there. The only time you see through-hole parts like these much anymore, if you buy some like super inexpensive consumer-y kind of gadget or something that's really, really super inexpensive to make. But I can guarantee you there are no through-hole capacitors or any kind of through-hole parts in your Apple laptop. So we have all of that. let's go ahead and put our voltage regulator back in. And now what do we have left? We've got IC. See? Look, we've got almost a fully populated board again. So now we're going to do the integrated circuits. There are 4. They are each different. And I don't even have to look them up, because I've been fixing 3003s since about 1985 or so. And after that long, you just kind of know it. There's one. I'm not doing these in any specific order. Looks like it's going to be time to order some new ones pretty soon, or more pretty soon. These are all brand new. Do you know that 3003s are probably the single most popular 80s and 90s intercom that there was? It was the model that launched the new series of modern intercoms. It replaced the IM3003. And it was hugely popular with builders and developers of the day, because it had enough of good features that people liked it, but it wasn't super expensive. It was substantially less than the 4006 that came out 2 years later. And it was sort of the go-to intercom system for especially builders or developers that did big subdivisions of houses. Alright, one more to go. There are, out here where we are, there are subdivisions of 200 and 300 houses, and they all have 3003s because it was actually a standard item in those days. And I always tell people that when I go to some of those subdivisions, it's actually somewhat easier to point out the houses I haven't worked on than the ones I have. I also always say jokingly that by the time we get them all done, it'll be time to do them all again. Alright, so there's our fourth integrated circuit. Now, as a visual check, to make sure we didn't miss anything, what you do is you look at the back of the board and you see if you have any empty holes. And if you look really carefully, I'll give you a second, you'll see that we have a couple empty holes. So what are the empty holes for? Well, we've got 2 right here and 2 right there. So these 2 look like it's a jumper link, 126. It's one that got overlooked. See, this is the trick when you do this is, if you take the whole board apart first, all you've got left is a bunch of empty holes. And as you go through and you fill up the holes, there's less and less holes. And if you have them all filled up, then there's no more holes at all. And that's what you want. Because again, one jumper link missing, something probably isn't going to work right. Alright, so there's that one. And then we have these two over here, which look like it's probably a resistor. It's probably R120. So let's look over here and see what happened to R120. Where is that? That's above this one. It's right there. But see, it's under this one right here, next to this integrated circuit. It's under the little blob of glue. So it got overlooked. We'll get rid of the blob of glue. And we'll do a little resistor transfer. Now some of you, if you're really paying attention, might have figured out at this point that we're robbing resistors off the donor board. And some of you might think, well, why is he doing that? Why isn't he using new resistors? Well, as shocking as it may be to find out, we don't keep on hand all of the dozens of different values of resistors that might go on a 3003 board, because they never go bad. Every once in a while you'll get one that's burned up, but that's usually up here in the power supply section more than anything else, and even that's not that common. Actually, it's this big giant one right here that usually fries first, because people don't get their sets fixed when they should, and then it gets hotter and hotter and eventually it crumbles and falls apart. But the little tiny half-watt resistors down in this end of the board, they never go bad. So it's not practical to have dozens of values of resistors to fix a board like this that you're only going to use maybe once or twice a year. Doesn't make any sense. It's also very time consuming to sit there and look them up and find them and figure out where they go, and it's just a lot to do. So now our board has been repopulated, and we'll do another quick visual check here to make sure we don't have any holes, and also to make sure that everything is soldered correctly. Looks like it's okay. See, here's a mistake. This is why you do the visual check. So right here is the lead for one of the little white jumper wires that's poked through, and it's soldered, but it actually is kind of long, and it was bent over. This is why you're supposed to clip your leads. It was bent over and touching the pad next to it, which is in a different part of the circuit, and that would be bad. That's one of those kind of things. It probably wouldn't blow anything up or wouldn't damage anything, but it certainly would create a problem, and it could take you a lot of time to look for it, to figure out what it is, and it's also kind of disappointing when that happens. I think everything looks pretty good. So let me go ahead and clear away some of the jumble, and we'll get our master station back, put it back in, and see if we did a good job or not. Alright, so before we put the board back in, put our knobs out of the way, we're going to take the hinges off, because we don't want them flopping up, because see, there's no insulator on the back of the board yet, it's just all solder points. We don't want these flipping up and shorting out the board, so that would be bad. So we'll do that. We've got to put our volume slides back on, and we'll put our little support bracket in. We'll temp fate here and make a wild guess that we did a good job. And it's going to work. See, when you do a major thing like this, and this is fairly major, there could be other problems, because as you recall, we did not plug it in, we did not try it or test it. We simply got to work on it. So I'm just going to put one screw in for right now, because I don't want to tempt fate too much. You know, if you tempt fate too much, fate likes to reach around behind you when you're not looking and slap you in the back of the head. And I would prefer not to have that happen. So we'll connect it all back up. That looks right. We need some power. Make sure it's set correctly. Yeah, we're good with that. Go ahead, hook it up. That. Hook up an antenna. Now they've got an odd antenna set up here, so this is going to be kind of exciting. That'll probably work. Now, if we did a good job, it should light up. Look. You can't see. It says 8 o'clock, which is rather interesting. We'll turn power on. We don't have anything over here. Oh, maybe dirty switch.
There's your first pitch somewhere around 6:45 in the p.m. Hank Schulman, our Giants insider, joining us at
Everybody likes a baseball game. How about a little FM? See, the switch is kind of dodgy. There we go. I'll have to clean that a little bit. FM. Reception at the shop lately has been terrible. I think it's because of all the fires, but not really. That seems all right. Go back to the baseball game.
And I'm sure there have been others. But last night, when you block a guy, and Tom, you know this because you played. When you stone a guy at the rim.
So let's try the chime module.
And he's about.
That works.
With your offhand, by the way.
And let's get an intercom speaker.
And he was going glory. We're going to get this game won. We're going to get off this good foot. And finals, here we come. And then Adebayo comes from across the side and meets him at the summit and says, no. Again, I'm probably being hyperbolic. Find me a
IS3005 terminal board.
No, just watch it over and over. It is wow.
It's a great block, but no question in my mind, LeBron's is the greatest block I've ever seen. Not even a question. Well, because the chase down, Game 7, and
Speaker
where the
plays.
It was at the very end of the game.
Intercom time.
That was when both teams were struggling scoring, and that could have put them up 2.
That could have done
and that kept it a tied game.
Door talk. Door listen. Turn it up back here. There you go.
And lots of yellow.
Inside talk. That works. From the remote, door talk. That's just feedback. That works.
I mean, that was
Monitor.
an absolute bucket.
Works.
All of a sudden, there's this streak at the corner of my eye coming from the left. And it just...
Yep. It works. We did it. We fixed it. The only thing I see
all of a sudden he was there. Like,
is,
LeBron was there.
and I think you can see this. There. that'll be better. This is, we're listening to 680.
Okay, all right.
Knocked it away.
I'll give you that.
I thought
There's no decimal point on the display.
I knew when I saw it. I go, as soon as I saw it,
Same thing, clocks. This
Before
switch
the
really needs to be cleaned. Alright, so this is supposed to be like 92.1. And we jump way up here. This is 107.3, and again, no decimal point. So the lack of decimal point is a problem with the display driver IC here. And we're not going to do anything about that. That has nothing to do with the water damage. It has to do with the problem that happens to the driver chips on 3003s. It's not a big deal. It was like that before they sent it back in to me. And it was probably like that when they sent it to me 6 years ago. But I don't really remember. And there's nothing in the notes about it. And it's not a big deal because people kind of get used to it. And if you don't tell them there's supposed to be a decimal point, they don't really worry about it too much. So there you have it. That's what it takes to fix a water damaged IM3003, and this one was not actually all that bad. I have done many 3003s that you've got damage on all three boards: main board, display board, tuner board. Display board can be usually resurrected. Tuner board is a little more dicey because it's got on it, here's one, 3003 tuner board. It's got a variable condenser here which does the actual tuning, plus it's got all these little alignment coils, and if this gets water in it, it's all done. You would have to replace this, and this is not a part that's you can buy separately any longer, and you'll never find, this was designed in the late 70s, early 80s, and you're not going to find a replacement for this, and it's not really a generic part. There are dozens and dozens and hundreds of different types of ones like this, and it would have to be the exact one, and it's not worth the effort. So if you've got a massively damaged tuner board and the variable condenser is damaged, it's time for a new board. And then you keep the old board and you scavenge your other parts off of it until there's nothing left, and then you throw it away. I hope you found this interesting and helpful, and you thought you wanted to be a NuTone service repair guy. If you did like it, please give it a thumbs up on YouTube because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.